Okay, we're going to do basic timelines here, and we use timelines. These timelines are used when we're doing more complicated interest rates, things with, well, just problems that involve changes in the interest rate. Let's take a look at one. You got 50,000 Rand, you put it into a savings account. For the first 3 years, it's 12%, but it's compounded half yearly, twice a year. And then after that, it goes to 18% compounded monthly. The money's left to grow for another 4 years, so that's 3 plus 4, that's 7 years altogether. The end of the calculate what the money is, the future value at the end of 7 years. Well, let's just try this. Let's draw a picture of it. At T0, that's when you begin. There's T1 for the first year all the way to 7 years. Because it's twice a year, it's 3 times 2, it's 6. That's the number, that's the power you put it to in your equations. And it's 12% compounded half yearly, so it's 2 times a year, so you put a 2 under there. The last 4 years, 4 times 12, that's 48 months, it's 0.18 over 12. Now, all you got to do is put that into the formula, so it's A equals P times the interest rate. Well, there's your P, it's 50,000. There's your interest for the first 2 years, 2 times 3 is 6, 0.12 over 2. And there's your interest for the last 4 years, 0.18 compounded monthly, 18% compounded monthly, and 4 times 12 is 48. Just put that in your calculator, and that's your answer. And that's all there is to it. In fact, I'm showing you here, there is another way I like to, I'm not sure I even like it so much anymore. I used to call the first amount A1. So that's this thing. And now A1 gets multiplied by this interest. There's no need to actually break it up. It's the way I used to do it. That's how I get my second amount. And I get exactly the same answer doing it this way. I write it in this way, and I actually put this into my calculator, or I type this out and I press equals, and then I times it by that, and I get my answer. But it's just the same thing. Now let's take a look at a different, make sure you don't round the answers and put them down. Let your calculator do all its work so you get an accurate answer. Let's try another question. What if you had a thing where you had Jerome here, and he invests money at 16% per annum for the first 2 years. Well, there it is, 16% compounded quarterly, and that's 2 years, so it's 2 times 4, it's 8 quarters, and then 15% compounded monthly for the next 4 years. So that's the remaining of the term. The future value, that is at the end, it's 20,000 Rand. So how can I work backwards? Well, there's a hard way to do it, and it's the way I used to do it. But this is how you do it. You want to figure out what this P is. You've got the A, so you can use the formula. The A is 20,000. You're trying to figure out P. 1 plus 15% over compounded monthly, 4 years. You just divide, and you get that amount. And then you work backwards again to figure out what this P is. So we've got this amount. We want to figure out what we started with. Now, this is the way, and you divide and you get your answer. But hey, there's a way, way easier way to do it. And I think it's the way that Ms. Bolkers is teaching people how to do it. And you know what? It's way better. If you want to go backwards in time, all you do is you multiply it by the interest, right? But you make it negative. So take a look at this. You just take 20,000, you take these 4 years worth of interest, instead of putting 48, put negative 48, and you'll go backwards in time, and you'll get that answer. And then 2 more years, that's 8 quarters, negative 8, you go backwards in time, look at that, you get the same answer. Wow, that's really a whole lot easier. So you put in negative 8 for the 2 years worth for the second part, and negative 48 for the 4 years. If you want to go back in time, just multiply by the negative months, and you'll go back. You'll figure out what the investment was you started with. You'll go backwards in time. And boy, that is really easy. And I should have been doing that all along. I mean, I get the right answers, but Occam's razor, there's a thing in science, says if it's simpler, wow, you should go the simple route. It's better. Okay.